So the axis of symmetry, I'll abbreviate it with an acronym, axis of symmetry, can be calculated with an equation, or we could calculate it by looking at it. Let's do it first by looking at it. If we were to plot the point on the Ferris wheel as it moved around the circle over time, we would get the plot of some trig function, sine or cos, and we would see that it would oscillate between 1 meter off the ground and the max. What would the max be? The max would be 29 meters. It's one more than the diameter, which was 28. You could see that our axis of symmetry on this function is right through the center. We're actually given that point is 15 meters off the ground. The question says, where the central axis is. It won't always say that though. So how would we calculate that if it was not given? We could use a equation which we have for all axes of symmetries. It is the max plus the min, unlike the equation for amplitude, which was max minus min. Axis of symmetry is adding it and dividing by 2. So we should get 29 plus 1, because it was 1 meter off the ground, divided by 2. So 30 divided by 2 is 15, and our units are meters. Try not to be confused about what an axis of symmetry is in a trig function, because you've seen axis of symmetries in parabolic functions being actually symmetrical, where it's a mirror image on one side as the other, and this is quite clear that it's an axis of symmetry. In sine or cos functions, it's not really perfectly symmetrical, but that's okay. We still call it the axis of symmetry. It's not an exact mirror image, but it is the midway point between the max and the min, and it is how we calculate the amplitude.